There we go. I think I have audio now. Let's start. So this is the class for databases, in case you didn't know. Can you all hear me? Yeah. Okay. So we're going to talk about databases in the next 3 weeks, and we're mostly we're gonna work on a database called MySQL. Some people say SQL instead of SQL. I usually say SQL. Which is MySQL is what's called a DBMS, a database management system. So SQL is a standard way of querying data in a database. And there are lots of different type or DBMSs. Maybe you heard about Postgres, maybe you heard about Microsoft SQL, MySQL as well, Oracle, they also do some SQL stuff. Lots of different ones. They are, I would say, like 90% similar, and then they each have like features that are unique to that particular database management system. We're going to use MySQL because it's free and it's widely used in the industry as well. But if you know how to use MySQL, you also know how to use Postgres or Microsoft SQL or whatever it is, the other ones.
Most of them are similar.
Yeah, they're similar. They have some different features, and some of them have different ways of doing the same thing. But as long as you know how to look it up in the manual, then it's easy. I would say 90% the same stuff. So the reason they're called relational databases is because they use something that's called the relational model of data. So when you've been having JavaScript, you had classes that had relations to each other. Let's say you had what application have you been building in JavaScript most recently?
Recently, you're building a
contact list or something.
Person, contact.
Yeah. So they
have a name, ID, and some other details.
Yeah. And they have relations to each other. So, like if it's your phone book, or let's say it's a phone book, then you have contacts in your phone book. So it's different entities that have relations to each other. So the relation model of data is best described by you have different entities for the database, and in those entities can you have different tables in the database. All those tables have rows, and those tables can have relations to each other. So let's say you are a car dealership, and you have two tables. You have a table with cars that you have for sale right now, or you have had for sale in the past, and then you have a table with customers, and the customers have a name and a phone number and everything, and then you want to relate these two tables together. That's relational data. The car has a buyer, the buyer has a name and a phone number, all that stuff. That's the most simple explanation for the relational model of data.
They will be having the buyer's information also in the other database?
Yeah, you can think of it as I can actually show you this because this is the easiest way to understand it. So think of it as a spreadsheet, Excel, or maybe this is too small. Can you see that? Yeah. So think of it as an Excel sheet. So this is two tables. You have a car table and you have a buyer table. So in here we have 5 cars. They have a unique ID, brand, what year they're from, and the model of the car. And then you have buyers for the cars, customers, whatever you want to call them. And right now they don't have a relation with each other because we haven't listed anything. But let's say we wanted to list next to each car if it's sold or not. Then we put the buyer ID in here, and we have ID 1, 2, and 3. So let's say ID 1 bought this car, 2 bought this car, 3 bought this car. And this one has not been bought because there's no ID in it. It's a bit noisy here. So now you have a relation between the cars and the buyers. even though you have two different tables that contain the data, but they have a relation to each other through the ID, which is what's called a foreign key. You can always think of the databases as simply just spreadsheets if you want to relate it to something you already know. Let's get back to this thing. So in this case, something that's called a schema or database within the different systems is basically just a way of grouping tables together. So in this case, this would be a car dealership schema, let's call it that. And you have two tables, the cars and the buyers. And this thing would be called a row or an entity, most likely. In some people call it a row, some people call it entity, but think of it as a row of data. Yeah, like rows in an Excel sheet. And the reason why, so what you've been doing so far, and know you wanted to save data, you've just been making JSON files, right?
Yeah, JSON files.
Yeah.
Array of objects.
Yeah, basically you just store the JSON in a file, and then that's it, and you store it on the disk. So the reason to use most applications, web applications, Facebook, Twitter, all the different applications, LinkedIn, all the stuff you can think about, WordPress websites, they all have some sort of database behind it that stores all the data and the relations between the data. Something like Facebook has a really, really complicated database, but in the end it's just a database. And the reason why you use databases is because, let's say you were storing stuff in a JSON file. You had a car database. Here we only have 5 cars and we have 3 customers, so it's not a big deal. Let's say you had 2 million cars and 1 million customers, something like that. Then saving it in a simple file becomes really impractical, and also becomes very bad performance-wise because it just doesn't scale very well. And what happens if you are writing the file to the disk and then the server crashes or the power goes out, and then suddenly you lose half your database, all your cars are gone. So these database systems kind of remove all those problems for you. They make sure that the data we're going to cover this more next time, but that the data that you store on the disk stays there, and that it performs really well, and that you can use the same database 1 million people at a time if you wanted to, without stepping on each other's toes. The most we can cover this.
The database system, where do you store? In a server?
Yeah, it's stored on
server or local.
You can do both.
It can be anywhere. You can run it on the same machine or on a distributed system, but it's still just one database. So you can just create it there and have the login so that the program will access and just retrieve the data.
Yeah,
Exactly.
yeah. You can have it on, as you said, anything from a laptop running locally to 50 servers all running one database, like scaling out so you have good performance and stuff like that. So the most, we can cover this really briefly on the board. We're going to have more of it next time, or in the third class. But the way to model these databases and visualize them is to use something called an entity relationship diagram, or an ER diagram. In this case, we have only 2 tables, cars and buyers. You would model this as model this as car and buyer for the customer. So these have a relation to each other. So in this case, a car has 0 to 1 customers, because if it's not sold, it doesn't have a customer. It's not linked to a customer if it's not sold yet. and a customer can buy any amount of cars they want. So it's a way to visualize the relationship between the tables. You have a car, you have a customer. The car can either be not sold or it can be sold to one customer. And the customer can buy 0 or 100 cars. How many cars you want to buy. You want to sell to that customer. And you can add as many tables as you want that all have relations to each other. So let's say that you had service agreements on your car. You have a calendar that has that the car has to go in for service, or like oil change, or whatever. After you bought the car, you can call that like what do you call that? Workshop?
Maintenance or something.
Yeah, garage. Yeah, I'm not a big car guy. And then you can say, well, what car is in the garage right now? Well, that is in, let's say you have a garage, you have 10 garages or whatever. And then you will have to specify what car is in what garage at what time. And this will point to a car, and that car will then point to a customer. Or maybe you point to a customer directly if it's a car they didn't buy in the same place. Car they bought somewhere else. But the gist of it is that you can draw as many entities that you basically want, or as many tables or classes that you basically want, and then you can give them relations to each other. It's a good way to visualize the database and get like an overview of how it works.
Yeah, sometimes you also see with the other diagrams that the different columns are represented as round. But it takes up a bit of space when you have to.
You do that here.
But that's also a way to do it sometimes.
Year, novel, grand. The buyer ID is represented by this. By the relationship to the object.
So it's all about the IDs. So
And in this case, each table has some sort of unique identifier, identifying row called ID, and they have a unique ID per table. So there can be a buyer with ID 1 and a car with ID 1, but there cannot be 2 cars with the same ID.
It's also what is known as a primary key. So it's the one you are always certain it's unique for that table.
Yeah, exactly. And whenever you put in, there's a technicality, but when you insert a new car, it automatically finds out that the next car ID is going to be 6. And in this case, it's going to be 6. So for this class, we have an example database, which is, I can show you the ER diagram for it. Let me actually, I forget how to do this, tools, there it is, reverse engineer. Next one. Yes, execute. There we go. So this is the diagram. Let's just zoom in on this one. So this is the diagram for this one. I can't zoom in more, I hope you can see this. So this is a task database, like a to-do list application. We have users to the far left. They have a name, an email, and a phone. Then we have a task, which has ID, which is the primary key, the unique identifier, title, description, a timestamp of when they were created, when they were last updated, and when they are due to be finished. And we have the user ID, which means which user that task is assigned to. And then you have a status ID, which links to the status table that contains the possible statuses that a task can have, which would be in progress, not started, and done. These are the three statuses we have. So we have three tables, and one in the middle has a relationship to the other two. So we can start by showing some of the most basic ways of querying. This tool is called MySQL Workbench, and you were going to install that after, but I'll just show you how this thing works. So the first thing here is just a way to tell the database that you're supposed to use the database called HYF1, because I have multiple over here. And then this is the basic statement to retrieve data from the database. So in this case, we're going to fetch all the users from the database. So you see we have 12 users with different names and different phone numbers. Some of them don't have phone numbers, some of them do. And you can, so if I wanted to only fetch the name and the email, I could select those two fields only. So this is the most basic statement you can make in SQL databases.
Yeah, that's what is known as the SQL language, or the structured query language.
Yeah.
That's what you're going to be using to retrieve the data and interact with the database.
Yeah. So you can also filter stuff out, or find rows where something is true or not true, which is what you use the where statement for. So let's say I only want people that actually have a phone number. So I guess you use this a lot in Node.js and JavaScript. You have if some condition is true. Think of this as the same way. This will check this thing for all the rows that are in the database, and then it will give you the ones where this is true. So in this case, we just want to find the ones where the phone number is not empty. So now we filtered out the ones where it was empty. We can also say I want the ones where it is actually empty, and then you will get the two people that have no phone numbers, Don Duck and Adam Smith. And you can combine this to as many with as many as you want using and or. So let's say we actually wanted. So in this case, it's going to give us everything, because we're just asking for the ones where the phone is null or is not null. But you can connect as many as you want using and or to find stuff in the database. Let's try it with task database. Here we find all the tasks. Some of them have a due date, some of them don't. They all have a status, and some of them don't have a user ID, which means they are not assigned to any specific user. We can try and play around with it here and say, so which task should we find? Any suggestions? What?
Can you zoom in?
On the bottom, or the thing is I can't zoom in on the bottom. I think I can only do it on the top.
Status IDs too.
Yeah. Let's try that. You can just move further down if you want. It's easier to see the bottom thing.
You just come closer.
We don't bite. Yeah. And you get the ones where status ID is 2. You can see it out here in the status ID column.
And user ID 1.
Yeah, let's
it's like a normal and they're both successful.
yeah. Both success.
Like, and if statement.
You can also say, let's say if we do or here, then you will get all the rows with status ID is 2 or user ID is 1. So we're going to get a lot more rows. So you see the ones where it is like a user ID. Basically, you can see user 1 has a couple of tasks assigned to them. And you can combine as many of these as you want. You can also match for patterns. So let's say we want to find everything about, let's see, something about, if there's something about books, let's say. So what this does is it finds out where the title column has some sort of value that has book in it. So you see we have write a book and remove face book from phone. What these percentage signs means is that this just means it has to be book, and then there can be anything after and before it, we don't care. If we said this, then we'd say it actually has to end with the word book. So if I do this, we're only going to get the first one. The percentage sign is just matches everything before and after what you're searching for. And you can also, this is a trick I've never used for anything, but I know it's possible. You can do this. This means the first letter can be anything. The second letter has to be an R, and whatever comes after that we don't care. So that's just the underscore. So you see the second place is always an R. I don't know when you would use this because I've never used it. In 10-15 years in database I've never used it, but it's there if you want to use it for something. And this is
it's a good way to implement a search feature.
Yeah.
If you need that, you can think of it a bit like a regular expression in JavaScript.
And as you can see, it's not case sensitive. So even if I write book with capital letters, I still find the ones that are called book with lowercase letters.
Can you also give like multiple book and something else?
Yeah. You can say we're title like book, and then we say or title like something with another something with wash, I think. Okay, you can do that as well.
Or you could search for both title and description if you wanted.
Yeah. Yeah, there's no books in description. You can also, let's say you only want, let's just try and select everything again. Let's say you want to order the tasks by title alphabetically. And you can do order by title. There are two possibilities. ASC is for ascending and DESC is for descending. So in this case it's going to start with A, B, C, so forth. So you see there's none with A, so it's just going to be B, C, D, E, F for the ordering. And then let's say you only want to fetch the first 5 tasks instead of everything. Because if you're only going to use the first 5 tasks, there's no reason to fetch everything. And you're just going to throw it away. And you do. What this does is it tells the database to start from the first row and take 5 entries. So it's going to show you the first 5 rows.
So here, like you don't use so much like parentheses kind of thing.
You can if you want. Yeah.
Yeah, you can group stuff together with parentheses. For example, if you have a complex where clause,
you can do this.
If you have both or and, sometimes it's nice to group them.
Yeah. So in this case, we could do.
there's also
Like
like in JavaScript, there's some statements have higher precedence than others.
So this, for example, here we want something where the description has book in it, or the title has book in it, and the status is too. And then we wrap the or statement in parentheses, both to avoid confusion, but also because it would. Yeah, you actually need this here, right?
Yeah, I think so.
Yeah, you do.
Otherwise, it would say description like book. Yeah, it would. Yeah.
We can try it. Let's try it and see what happens.
What are the precedent order?
I'm not sure about every statement, but it's in the manual, so you can find it out.
Yeah. So you see.
Otherwise, it will be from the right.
Like priority.
Yeah, exactly. Which one is the most important?
Yeah. So as you now I remove the parentheses and we actually get 2 rows. So yeah, it actually you need the parentheses, otherwise it's gives you the wrong, or it gives you the not intended result. I think we can, before we go further, we should probably have you all install the software on your machines. So we have some Macs and we have some
Max.
1, 2, 3 Macs and 2 Windows, right? Running Windows? Linux? Linux or Windows or Windows? Okay. So what happens when I'll just stop the recording.